Next, you have vitamin B2 or riboflavin. This also plays a role in coenzyme function for metabolism. Riboflavin is specific to calorie and fat metabolism. And so it promotes growth and development. It helps to process other vitamins, and it also helps to create collagen, which is a major component of the connective tissue in our body. Deficiency symptoms of riboflavin are linked to inflammation of the mouth area, could be of the skin, tongue. Also, increased risk of anemia is linked to inadequate riboflavin intake. Toxicity is very rare. Milk used to be delivered and it would be dropped off on the front door and you would have it in a yellow form. It'd be dropped off on the front door in a glass container. And it would be yellow because what happens is when riboflavin is exposed to sunlight, then it changes color. You get that yellow color. Now we have milk cartons. You don't have milk sitting outside. Today you could practically be arrested for that if you're selling or delivering that. But riboflavin in milk, if that milk is exposed to sun, is going to be what causes it to turn yellow. So you would see that back in the day quite a bit when it was dropped off in the front door. B3 or niacin is another coenzyme, helps to metabolize fats, carbohydrates, and proteins. This is responsible for DNA and cell formation. Remember that, DNA and cell formation, and it also helps to allow the cells to signal to one another throughout the body. A niacin deficiency is very dangerous. It's very uncommon in developed countries, but it's very dangerous. And because niacin promotes DNA and cell function, there are problems that can occur in areas of the body that have high cell turnover. So we're talking about the skin, and we're talking about the GI tract, and even in the brain. So skin, you're more likely to see skin breakdown, inflammation of the skin, or dermatitis, which you can see on the right side of the screen. Because there's a lot of turnover in the GI tract, there is also a link to diarrhea because there's a breakdown of the cells in that area, and also a strong link to dementia and even death if the deficiency is severe enough. Niacin toxicity, that's something that we can get from having too many energy drinks. It's not really that dangerous. It just causes like a little bit of a red flushing in the face, maybe some mild nausea, headaches, cramps, heartburn, relatively mild things. And we'd have to take quite a bit of niacin in order to experience that. Vitamin B6 or pyridoxine is one that we don't hear about quite as much. It's another coenzyme, specifically in protein metabolism. Helps to synthesize hemoglobin, a major component of our blood cells, and it helps to convert tryptophan into niacin. Deficiency symptoms of pyridoxine deficiency are poor growth and anemia. Vitamin B9 or folate or folic acid, this is a really important one. It promotes red blood cell formation. One part that's very important, plays a role in protein metabolism, synthesizes DNA. Remember that one as well. And then it also plays a role in cell function. But getting to red blood cell formation, what folate basically does is it allows cells to divide. So what happens if you look to the right side of the screen, you have something that is going to become a red blood cell on the far left, that blue and purple thing, the red blood cell precursor. If you have adequate amounts of folate, then what you can do is you can take that red blood cell precursor and divide it in two, and then you have two red blood cells. If you don't have enough folate, some of these cells are not going to be able to divide, and you'll get a big red blood cell. Doesn't seem that bad, but we'll talk about why that's bad on this next slide. Anemia is something we've mentioned a couple times so far. There's a couple different forms of it, but the main gist of anemia is that there's very poor oxygen transport throughout the body, and because of that, we're more likely to feel fatigued and tired. In the case of macrocytosis, what we have here is that the red blood cells are too big, and because the red blood cells are produced in the bone marrow, they're unable, a lot of these cells are actually unable to escape the bone marrow so that they can travel to the rest of the body. And so from that, we're not going to have as much of the oxygen transport that we need to function optimally. This here is probably the biggest reason why folate is so important for us. If mothers do not have an adequate intake of folate during pregnancy, then there's an increased likelihood of very significant birth defects. And these could be problems with the brain, although mainly they're problems with the spine or the spinal cord. In more severe deficiencies, you can see problems with the brain and even death of the baby. But again, mainly it's due to issues with spine or spinal cord development. And what happens is the neural tubes they should close. So you get normal spinal cord development that goes around the vertebrae, as you can see on that left picture of the vertebrae. In the case of neural tube defects, that spinal cord may not close completely and it may become very extended. And then as you can see, it'll kind of form solidly like that. So you have a picture that kind of looks like that baby in the bottom right hand of the screen. That baby did not have adequate closure of his or her neural tubes. So folate, by synthesizing and creating DNA, it's going to be able to close that up so you have normal spinal cord development in a baby. Little mini sort of nutritional trivia question. Folate deficiency symptoms are less of a problem recently because which of the following? First, grain products are now fortified with folate. Green tea is more popular. More people are drinking low-fat milk. Or taking vitamin supplements is more common. All right, so this should explain that. And we're going to go over enrichment and fortification to help give you an understanding of what our food supply does to help combat these issues linked to folate deficiency. First of all, you have enrichment. What goes on in enrichment is there's going to be some processing of a food. In this case, it's going to be generally of a grain. But there's going to be processing of a food. In that processing, there's going to be lots of nutrients that are lost. When you lose those nutrients and then you replace some of the ones that are lost, you enrich them. Secondly, you have fortification. This is like enrichment in that you're artificially, or not artificially, but not naturally adding nutrients to a food, adding nutrients that are not commonly found in a food. So food doesn't have it to begin with. Regardless of whether or not it's processed, doesn't matter. You're putting in new nutrients to a food. Enrichment, you have them, you take them away, and then you put some back. So a while ago, in the 1940s, during World War II, this enrichment and fortification process was largely started. You had iron and a lot of the B vitamins that were being added back into the grains. And now because of this, deficiencies like thiamine, riboflavin, and niacin deficiencies and folate deficiencies, those are extremely rare in the United States and in other developed countries. The last major one is vitamin B12. This is a coenzyme in folate metabolism and it promotes nerve function. Deficiency symptoms are very important. Macrocytic anemia is quite common. Macrocytic anemia, again, going a few slides back, that's just where the red blood cells are too big, and so they can't get effectively, or at least in sufficient numbers, they can't get out of the bone marrow in order to transport oxygen throughout the body. Other less common deficiency is nerve degeneration. Pantothenic acid and biotin are a couple less important ones. They are coenzymes in carbohydrate, fat, and protein metabolism. Deficiency symptoms are rare, but there is a slight link between deficiencies of these two nutrients and depression, and there's no known toxicity for them. Over the next few slides, what we're going to do is we're going to take a look at the different B vitamins and look at the different food sources of them divided by the different food groups. So purple, that stands for protein. Blue stands for dairy. Red stands for fruit. Green stands for vegetables. Orange stands for grains. See if you notice any correlation between certain food groups and sources of all of these foods. Okay, here is riboflavin. We have niacin or B3. Here is vitamin B6. Here we have folate or folic acid. And finally, here we have vitamin B12. So with that fresh in your mind, what did you notice? Lots of the grains had B vitamins, but also a large amount of the protein foods. Probably the most significant source of the B vitamins came from protein-based foods. Now, there are vegetarian sources of protein, but generally, the highest foods that have the B vitamins are going to be from animal-based foods. So people who are vegan or vegetarian, they have to be a little bit more careful with this, especially if you move back one slide, vitamin B12. It's pretty much not found naturally at all in anything except for animal-based food sources. Last but not least, we have vitamin C or ascorbic acid. Vitamin C plays an important role as an antioxidant. It helps to strengthen our immune response. And then for people who are vegetarian, it helps to make iron more bioavailable. And really, any vegetarian sources of iron are typically not quite as easy for us to absorb. We absorb about 1/3 of the amount of vegetarian iron that we do of meat-based iron. If we have vitamin C with that, we're more likely to have about that same absorption rate as we would with meat-based iron. And then vitamin C also promotes the synthesis of collagen, which is responsible for promoting the growth of or it's actually a component of our connective tissue. Now, with that in mind, back in the day, way back in the day, people that were on long sea voyages would commonly get issues that were linked to basically poor collagen formation in their mouth, specifically around their gums, like you can see in the bottom right of the screen. This is linked to vitamin C because vitamin C is primarily found in fruits and vegetables, and it was very difficult to have fruits and vegetables in sufficient quantities for these long trips where they were away from places that they grew, like on land. So a lot of times, way back in the day, you would see issues with scurvy, or basically this poor collagen production around the region of the mouth. Food sources of vitamin C are found in a couple other food groups other than fruits and vegetables, but primarily and in the greatest quantities by far, you're going to get them in fruits and vegetables. That's all for water-soluble vitamins. This next set of slides is going to look more at the fat-soluble ones.